average is 49 to 50. I usually expect the upper 60 to 70 for the average, and this time it's much lower than that. So I'm going to, even though I'm going to consider a curve for the midterm exam, but still it's lower than usual. So you need to work hard for the other activity. So midterm will be the 20 to 25% for the final grade, which means you still have a chance to catch up. But this time the interesting thing is the standard deviation is usually the lower 10, like the 12 or 13, but this time is almost 20. It's so wide, which means those who didn't start, it's so low. And I think that's because of the open-ended question. It's all or nothing, but still it's low. Okay, so but anyway, so you have a chance to check your exam online, the online laptop. So you can come by my office at 11 to 12:30 on Friday. So you can come to my office to check your answer, and especially for the open-ended question, if you answered a little bit weird but correct one, so you can, because I put all possible answer, but if you answer like 8 or something different way, you may not get the credit at the time, so you can come by my office and correct. And there are a couple of questions one question, LWP, nobody answered correctly. What is this LWP? Lightweight? It's a process, okay, it's a process, lightweight. But all students answer lightweight processor. I didn't expect this kind of a trap. It's like to make it easy. So lightweight processor. Processor is a CPU. Okay. Then all students answer the lightweight processor as the correct one. Actually, this is on the kernel thread and the user thread, because we have a number of user thread, number of kernel thread. We need to schedule. So for that, like the CPU scheduling, we need to schedule between. Then nobody answered correctly, but I didn't expect this kind of trap of the question. Surprised me. And also the P thread is not exactly same as the POSIX thread. P thread is what? It's a standard specification. Okay. Then using this specification, there are many the implementation of the thread programming. So that's only one student answered correctly. This one. So these two are the most difficult question. I don't think it's a really difficult question, but confused. Next time I will consider the different example for the lightweight processor. I didn't expect the processor and process are so confusing. Okay, so now Thursday, I'm going to open the office hour on Friday morning. So 11 to 12:30, please come by my office. Then please continue to work the project, the B part, and also even though we do not cover the topic of the project 2, you better start the project 2, because there will not be the extension of the second project. Also, especially for the undergraduate student. I know the undergraduate student got the much lower mark than the graduate student. It's tough. So one thing, I will decide the final grade only for the undergraduate student. Second thing, if you do the second project, which is optional, it's just an extra point, which means on top of your final grade. So like if you complete the second project, you will get the plus 20, the maximum, or the 25. Like that. So please work on the second project for the undergraduate student if you need the extra point to catch up the grade. For graduate student, definitely this is the required. So please start to work. Okay. Usually the second half of the full semester is in a hurry. We are going to have the Thanksgiving at the end of November, so it's a quickly final exam week. So please manage the time for better. Okay, so today we are going to hopefully finalize the chapter 7 for the deadlock management, then we can move on to the memory and the I/O management the next week. Or if we need the time, we will spend a little bit time on the Monday next week and continue to discuss about the memory management and the I/O management. Okay, so before we start, I think, oops, this is the last page. So this is a case of the deadlock. So this is the intersection, the full direction. So you can see the full cars weighting each other. So we can consider this situation as a deadlock situation. So today we are going to talk about what is really deadlock in terms of operating system and what is the definition, what can be the solution of the deadlock management. Okay, so for example, the last the class during the synchronization, we have the several different types of solution for the synchronization issue. First one is the software solution. And another one is operating system solution. Third one is a hardware solution. So, for example, the operating system, the software solution is not used a lot because we can understand the algorithm to solve the synchronization problem, but it will be the overhead. Each algorithm has a busy lock and a busy waiting, and also it should run every time. So mostly we are using operating system solution or hardware solution. For the operating system solution, operating system define the new data structure, which is called the semaphore. Okay, the semaphore is the data structure that keeps the list of integer. So in case we have 0 or 1, okay, so which means not the list of integer 0 or 1, which is called the mutex lock. So we can use the mutex, the data structure, as a lock. So, for example, to access the shared data, we can get the required lock, then release the lock. So for that, getting the lock, release the lock, we have the two operations, the wait and the signal. So it looks like the wait is the getting the lock, hold the lock, and the signal is the release the lock. So these two operations should be paired. Okay, whenever you access, because of that limitation, so all the operating system, from time to time, you can see the mutex lock problem, or something similar name of the lock problem, as a pop-up. So like the Windows 3.1 and 95 shows such a lot of the mutex lock, because there was the racing condition is a synchronization issue. So this is the operation. So for example, so one process 0, the wait for the shared memory one to get, and the P1 get the wait for the shared data 2. Then the P0 before and the process it needs the S, the 2. This one at the same time request S1. So this is process 0 is holding S1 with the wait operation. In other words, it's a lock. And also same time P1 lock the S2. So using the wait method. Then wait for the S2. That is held by the P1. At the same time, P1 is requesting held by the P0. This is the deadlock. Okay. there's no other solution. It's keep waiting until one of the process is releasing the resource. So we are going to see what this is one simple example of the deadlock. Actually, deadlock happen a lot in our real life, whether or not you realize. Okay. Sometimes if you go to the suburbs, so I'm holding the cream, but the next one is the holding the sugar, then the waiting the others. And at that time, we need to do something. We cannot wait forever. Then if you are generous, you can give yours to others. Okay. So that is also deadlock situation. Actually, deadlock happens a lot in our real life and the daily life. So formally, we are going to define what is the deadlock and how to solve that. This is not the only case to process or the share data. Sometimes we can consider the multiple process, like the 4 or the 5 process. Like for example, I think the intersection is one of the examples. If we regard the car as the process, and another car, and another car, and another car, and this is the shared data, the intersection, they need to close the intersection. So we can consider this one as the shared data, and this is also the resource. This one is a resource. This one is a resource. This one is a resource. It's held by each process. Then they need to get another one. Okay. Then we can decide that this is also deadlock situation. So multiple process cases also happen such a deadlock. In our definition of the deadlock, we will define the general case, which means the multiple case and the multiple resources. Okay. So I mentioned many times the process and the resource. So there are two types of the two things involved in this the deadlock management. One is the process, and another one is the resource. We can consider this is the kind of consumer or whatever, but we are going to define the process and the resource. When we talk about the process, we know we have been talking about discussing about the process, how to create the process, how to simplify the process as a thread, and synchronization issues, scheduling. Those are the processes. Okay, process is the data structure in the memory to load the sequence of the instruction that can be accessed by the CPU and something like that. Then they need to use the something resources. So resource is the what? It's everything in your computer system. So what types of the resources you can imagine? Hardware, like the CPU resource, memory resource, I/O resource, anything. So this is a hardware resource. So hardware is the only type of the resource that we can use. Also software, okay, like the what? Any algorithm that you define or the variable you define. So these are the software. So when we talk about the resource, it's not only hardware, the memory, shared memory resource, but also it can be anything, including the software or data structure, everything. Then whenever the processor access or the use such any types of resource, actually operating system as the basic mechanism. First, request certain resource, then use, consume, and whatever you use that resource. Then after you use, release the resource. So the reason why we need to release every time, first the request is because we sometimes it may cause a synchronization issue or sometimes cause the deadlock problem. So we need to always request to access the resource. If granted, then finally we can use them. Sometimes the synchronization problem will be involved before you access. That is the critical section problem. In case it's a shared data with the other processor. Then once you did, always we need to release because we have a limited resources so to be free for the other processor we release. For example, how to create a file in C or C++. Anyone who knows the function used in the C or C++? Add open. You can open the file. Open file. The F open. Then you can write the data. Then after you finish, close. F close. File close. So it's a request, use, and release. And what about the memory? How can you get the memory? How can you allocate the memory? Malloc. So memory allocation. It's so funny. Usually, when this kind of system library or name was developed, they use just a simple word. So I thought the malloc looks like a very sophisticated wording, but it's a memory allocation. So then you can use the memory, okay? Then after you use the memory, you can deallocation. So any types of the resource, whenever you access such a thing, request this one. So in this is called the model to use the resource by the processor. So we are going to use this kind of model to define the deadlock, the definition of the deadlock. Before that, so we intuitively understand what is the deadlock. It looks like there are multiple processes and also shared data. So formally, we are going to define. So first, the resource. Where is the resource? Yes, the resource. This resource can be accessed, used by how many processes? Only one process, right? So if you allow the multiple process access the shared data, there might be no problem. So you can run the request of the process 1 to access the S2, even though the S1, even though S1 is used by the process 0, it can be granted because it's a shared data. So similarly, if the S2 is shared, so you can grant in case the P0 is request this resource. So which means in case of shared the resource, there might be no problem. There will not be any deadlock situation. However, in other words, if the mutual exclusion, so if the resource is a mutual exclusion, which means only one process can access the shared the resource. At that time, it may cause the deadlock situation. So that is the first requirement to be the deadlock. Then, second thing is, even though the resources are the mutual exclusion, only one process can access the data. But if, in this case, the process 0 is holding the resource, the S1, then request, wait for the another one. And also same time, P1 is the holding this one, current one, and request. Always, whenever you see the deadlock situation, hold this resource, wait for this. Hold the resource, this one. So, whenever you see the deadlock situation, always you can find the process is holding, a man is holding something, and the request another. So, this is called the hold and wait. So, hold and wait. So, second, the requirement of the deadlock situation is first the mutual exclusion, second is hold and wait, and the third one is, in this case, if P0, in case something problem, then the P0 release, I don't need, okay? Then later I will do that. So for example, he is holding the cell phone, I'm holding this one, then keep waiting. At that time, if I just give up to use any resource, then he can use. So there might be no problem. In case it's greedy, so which means never release the resource that I'm holding and that he is holding. That will be the problem of the deadlock. So to define such a situation is the non-preemptive, which means it will not be resumed later. For example, what is the example of such a non-preemptive? Many of the resources are non-preemptive. Okay? So for example, process itself, if the process give up, you need to restart, okay, from the beginning. So for example, if you give up this resource, this car will be towed away. Then start again to enter this one. And this car, if the preemptive and give up and towed away and start again for driving. Okay? For printing, so if the printing is the kind of process is holding the print, and the printing you cannot preemptive. So there are a lot of resources it cannot be, and the process it cannot be preemptive. So, however, in case the preemptive, there might be no problem. So another the requirement of the deadlock is it's a non-preemptive. It cannot be stopped. It cannot be resumed. Okay. So in case of greedy, it will be deadlock. So third one is a non-preemptive. Fourth one is even though hold and wait, I'm holding the resource S1 and wait S2. I'm holding the S3 and waiting for S4. Hold and wait, hold and wait, hold and wait, hold and wait. So, but this is not a deadlock because this one can eventually get the resource. S1, S2, S3, S4. They are not, okay, the relative, even though hold and wait. For example, I'm hold here's the I forgot the name of this. This is not earbud. Headphone. So I'm holding headphone, but he's holding his headphone, but he's requesting the laptop. Okay, I'm requesting camera. There might be no problem, even though hold and wait, even though it's a mutual exclusion, even though it's non-preemptive, there might be no problem. Which means that wait should be wait each other. In other words, if we generalize the multiple processes, and the end process is a circular wait. Their wait. For example, this one, wait this, wait this. It's a circle. It's a circular wait. In case of the full process, wait, 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 like this. If there's any break, like this one wait for P, another resource, this is not a deadlock situation because eventually each process will get the resource. When this one is done, this one, and completed. So another requirement is a circular wait. So there are 4 requirements of the deadlock. So somebody formally define, investigate what is the really characteristic, what situation of the deadlock. Intuitively, we understand what is the deadlock, but to solve that, the deadlock is not a good sign. Okay, deadlock is a really expensive and complicated problem in the operating system. So characterize what is the really characteristic of such a situation. Then realize that there are 4 requirements. So one is a mutual exclusion. It's not shared. If the resource is shareable, then there might be no problem. Everybody can use for example, laptop. Then even though the number of locks over there, so it will be okay. Then the second is hold and wait. So because I'm holding certain, so I'm greedy, then wait for the other. Then that causes a problem. If I do not the wait or I do not hold, so it will not be problem. But such a wait should be wait each other. In other words, a circular wait. Then the request is non-preemptive. If preemptive case, you can stop and resume again. But in case it's non-preemptive, that goes the deadlock situation. So this is the requirement. So then we are going to apply to consider this requirement in the real operating system situation. To do that, we are going to model the process and the resource. As the process is the circle. Resource is like the square. We are going to use this one to model, to simplify the problem. Then, in case of a resource, so for example, hard disk drive. How many hard disk drive you can have? 2, 3, 4. In case of a CPU, how many CPU can I have? Multiple CPU. So if we generalize such a multiple instance case, like for example, if you have the 4 instance of the R, this is the each instance. Like in case of a hard disk drive, and this one is a 1, 2, 3, 4 hard disk drive. Okay, then as we define such a mechanism of using the resource, first request and use and release. So first the process need to request. So that request is the model as the arrow from process to the square resource. But it's not assigned. Okay, it's not granted yet. So it's the direction of arrow is the outside square. Okay. Then if that is granted, like for example, one of the resource is granted to the P0, then it will be like this. From one inner the resource, inner square to the process, which means the resource, for example, this is a hard disk drive. Let's say the resource, the 1. The resource 1, this is the R1, the R10, R12, I1, R1, the 2, R1, 3. R12 is assigned to the process 0. This is assigned, the use. Then if you are done, then we can disconnect. So this is a request and assign. So depending on the direction, it is different. So for example, if you have the multiple process at the P0, P1, how can we represent this case? Let's say the P0 has the resource is the one single instance. We have the one single instance, so that is R. So 1. And there is another one, and R2. So P0, PR1 is assigned to the P0, and R2 is assigned to the P1. Then the P0 requests R2, and P1 requests R1 held by P0. Then this is the diagram, process and resource diagram. Okay, for the process, it's still called the resource allocation graph. It looks like the graph. How many different types of node? Process and resource. Then we have edges. It's a directed edges. There is a direction. Each direction has the different meaning. So this is called the resource allocation graph. Then this one model the process and the resource. So from this graph, each resource is the mutual exclusion. Then whether hold and wait, and this will not be backup resume is non-preemptive. And these three, especially the number 1 and number 3, is a characteristic of the resource. So it's not represented here. Okay? So then we assume this is a mutual exclusion and the non-preemptive. Otherwise, we don't have to worry about that. Then, at that time, the problem is what? Whether this is a hold and wait and circular wait. So how can we identify? How can you find whether this one and this one is satisfied in this graph? Whether this graph has, what is this? If you twist it, it's a circle. Whether there exists a circle or not. So deadlock problem is right now converted to the what? Whether we can find a circle from a graph or not. Okay? This is a kind of the model approach to solve the problem. Instead of directly solve this problem or case by case or something different situation, instead we model, generalize such a problem. Then using the data structure, in this case what? The graph. Using the graph, we represent the deadlock situation. Then the problem of the deadlock is the same as what? Circle. Whether we can. So if, for example, if there is a circle in this the resource allocation graph, that's the deadlock. If not, if you cannot find the circle, there is a fine. So it's called the safe state. No deadlock. So we can convert the problem into the graph. Using the graph, we can represent such a deadlock. So we can say if you can find the circle from a graph, it's a deadlock. If you cannot find the circle from a graph, it's not the deadlock. So what about the finding a circle from a graph? What is a graph, by the way? It's a data structure. When did you learn? It's I think the CS 102. You're advanced, even before advanced in the CS 102, right? Tree structure and the graph structure, stack, queue, and linked list. Do you remember that? So these are it is true. Many of the data structure that we are using in the graduate level, even the senior level, we already learned from the CS 101 and 102. So, what is the difference between the tree and the graph? Both of data structure use the node. Plus what? Edges. But tree has different types of node. One is root node. Starting. There is a starting. And next? Child node. And leaf node or terminal node. And there is a relationship of such a node. It's a parent and child relationship. So always parent to the child. This is the tree structure. So tree structure used a lot. For what? It can be used for indexing. It can be used for search. Okay? And there are different types of tree structure, like the binary tree or a lot of. So it's mostly one of the mostly used data structure. On the other hand, what is a graph? Is there any the parent and the child different node? No, it's always just a node. And what about edges? There's a direction. General graph structure does not have such a thing, just the edges. So we can define the graph as the G equal to V and E. Set of vertex node, set of edges. Sometimes we can have different types of node, like this one. How many different nodes? 2 types of node. We can have the different types of edge, like the directed edge. In case of direction, it's called the directed graph. The benefit of using, what is the benefit of using graph? Comparing to other data structure, hash structure or any other structure. What relational model if you are taking the database? What is the benefit?